Greetings and welcome to today's lesson on graphing array. Now, we've been doing a little bit on graphing line. Now we're going to work on graphing array. So let's start out with, well, what is array? So array, it's a lot like a line, and in fact we use it in English all the time, right? A ray of sunshine, right, is light that emanates from the sun. So array has a starting point. And then travels infinitely away from that starting point. What do I mean by that? Let's take a look at a very simple example, right? So we're going to put our graph here, okay? And we have ourselves a point. Let's just pick a point. And then we have a ray, and the ray just goes off, and it has an arrow at the end because it goes on forever. Starts at our point, and it goes on forever in one direction, okay? Up, down, left, right, a little bit up, a little bit down. Could go in any direction, okay? But it has a starting point, and then it goes from there. Unlike a line, which goes in both directions, okay? It's going, lines would be going, this line would just be coming down and up. It would be going that way, and it would be going this way. Rays don't really have slope per se. I mean, they do. I mean, don't get me wrong, they have slope, but we don't name slope on a ray as much. Now, what causes us to have a ray? Let's talk about that a little bit too. Rays can be any time that you have something where maybe there is nothing the other direction, right? Like if we were to talk about something that, I don't know, let's say growth. Right? Can't be negative because you start at 0 and you grow. Well, then that's a direction. It can only go up from there. Okay? Or, you know, once it gets to the end, it could only get to 0 and it could stop. So it could be it could be going down the whole time, but it would be a ray sort of going the other direction. If it looked something like this, that would be an acceptable ray. There's all kinds of things that will cause a ray, but the biggest one for us, and the one that we're really going to focus on, is when our domain is described with an inequality. Okay, that's going to be what creates a ray for us when we're graphing. Okay, so a ray has a starting point and then it goes. Okay, it could go up, it could go down. Okay, it doesn't have a requirement. It's not. It's what the ray describes. So we're going to see some of these. Okay. Now, in order to really understand graphing array, let's make sure we remember how to graph a line. So we're going to graph a line, then we're going to graph a ray. So let's start with, and again, we don't go through a lot of detail here. We just say graph, and then we get ourselves an equation. Y equals, let's make it easy. 3x, say plus 1. Now, I'm going to show you a quick way to do this probably in the next lesson, I think. So we're going to stick with the slower method because it's actually really important for us for what we're going to be doing by graphing rays. So it's even more important for that. And that is we're going to make a table. And in that table, we are going to put some values in for x, and they're going to generate some values for y, and then that's going to give us the ability to graph, to plot those points on the graph, connect them, and create the equation of the line. Now, we can pick whatever points we want. We can pick any x value that we like, doesn't matter. I always suggest picking easy numbers. I always suggest one of those easy numbers should always be 0. And I still suggest picking a negative number because when you get into some things that we're going to see later on in the year, or even next year or the year after that, you're going to want to use negative numbers because they're going to act differently than positives. So although 0, 1, 2 is probably really, really easy, -1, 0, 1, I think is just about as easy and maybe a little bit more useful down the line. So we're going to do that. So we're going to pick -1, we're going to pick 0, and we're going to pick 1. And then we're going to plug them in. So y equals 3 times -1. That's -3. -3 plus 1 is -2. And we'll do it again. Y equals 3 times 0. 3 times 0 is 0. 0 plus 1 is 1. We'll do it one more time. Y equals 3 times 1. 3 times 1 is 3. 3 plus 1 is 4. And we've now created 3 ordered pairs. negative 1, 2, 0, 1, and 1, 4. And now we can graph that. So negative 1, comma 2, right there. 0, negative 1, my bad. Let's see, I make mistakes too. Negative 1, negative 2. So I knew something wasn't right. Should have left it there just to show you what it looks like. 0, 1, and 1, 4. Not very well drawn, I must say. Yeah, it needs to be closer to here. There we go. Just to make my graph a little bit neater. And there's my line. Okay. Again, drawing freehand, not always the best. Hopefully you'll have them, or maybe you'll even have your own graph paper. Now, if I had left that negative 1, 2, I would have known something was wrong because I'd have had this point sitting right here. And that would have been a real strong indication to me. If I got a point here, a point here, and a point here, well, I know something's not right. I'm graphing lines. That's not making a line. So I know something's wrong. I can go back and fix it. Okay? So it's always, that's one of the other reasons we want to pick 3 points and not just 2. 2 will never reveal a mistake because 2 points will always line up. Because if these were my 3 points, how do I know it's not these 2 that are right or these 2 that are right? All right. So you always want to pick at least 3. I've seen places where they go as high as 5, but I'm a big fan of 3. And this is, again, very neat, very easy, because I've picked 3 points that were very mathematically easy. Okay, yeah, the negative might have been not the simplest, but again, I'm thinking ahead for you, because when you get into high school, you're going to want to be able to deal with negative numbers, and you're going to want to be able to make a table with negative numbers, because again, they act differently than the positives when you get into things that are not straight lines, when they're not linear. Okay, so again, I'm thinking ahead for you. But again, that's graphing a line. Now again, I'm going to show you a way to do it without any of the need of all this, to just be able to take this equation and boom, boom, and be done in a blink of an eye. Okay, we're not quite there yet, but we're almost there. But again, why is the table so important? Because the next step is graphing array. Now, when we graph array, I'm going to graph the exact same equation. And the only thing I'm going to change is, instead of just saying graph y equals 3x plus 1, I'm going to say graph y equals 3x plus 1 when x is greater than or equal to 2. Now I've put a restriction on x. And this restriction is in the form of an inequality, meaning I can't pick values less than 2. I have to pick values 2 or greater. Okay? And again, there's lots of situations where this will happen. Sometimes this is because if it's less than 2, we just don't care. Like there's, you're looking at some kind of growth, or you're looking at some kind of financial situation, or, maybe you're into fantasy football and your team only wins if he scores 2 or more points. I don't know. Just throwing things out there that I can think of off the top of my head. But we have this restriction, this limitation on what x can be. So when I go to make my table, I'm still going to do the same process. The only real big change is when I go to pick my values for x, I have to adhere to my restriction, my inequality that tells me I'm only allowed to pick values 2 or greater. Now, I'm going to pick 2, and then I'm just going to pick nice, easy numbers from there. So I'll pick 3, and I'll pick 4. And I'll talk to you a little bit, because it's going to change when it's not equal to. Right now, this is greater than or equal to, and then we'll talk about what happens when it's not equal to. So when it's greater than or equal to, same process, everything else stays the same. I plug in my new numbers. So I'm plugging in the 2. 3 times 2 is 6, plus 1 is 7. Then I'll do it again. Y equals 3 times 3. 3 times 3 is 9. 9 plus 1 is 10. And y equals 3 times 4. 3 times 4 is 12. 12 plus 1 is 13. And I hope that you can see the same pattern. I should have pointed it out on the last one, that as this is going up by 1, these are going up by 3, and that's a function of this right here, this the slope. And again, we'll talk more about that in the next lesson. And now we've created our set of ordered pairs, 2, 7, 3, 10, and 4, 13. Well, I'm going to need a little bit bigger graph because obviously I'm getting to a kind of a high number there with 13. So again, here's my x and my y, 2, 3, 4, and since I can only start at 2, I don't even have to put anything back here. I only have to go out. So now I have to go up all the way up to 13. So 1, 2, 3, 4, 5, 6, 7, 8, 10. Oh boy. So 11, 12, 13. Way up there. So 2, 7. 2, 1, 2, 3, 4, 5, 6, 7. Make sure that's in the right place. 3, 10. And 4, 13. Now, here's where it kicks in, where it's a ray and not a line. If it were a line, I would just connect the dots, put an arrow at each end. But as it is, this is where I started. And I'm going away from that spot. Boom. There's my arrow. That's my ray. I started here. I went that direction. I cannot go any other direction. I can't come this way. I'm not allowed to because that would give me an x value that is less than 2. And I'm not allowed to have that. It also presents us with the next question that often comes up with this is what's the range? When the x is restricted, y is also restricted. Okay? What is the restriction on y? Well, the y values started here at 7 and they went up. So they went to the greater than, and they could be equal to because they started at 7. So they were greater than. So this would be the range. They often ask us what the range is when they restrict our domain. They love to ask that. That's a great combination of, do you understand that if we started here and went this way, we could only go that way along the x and that way along the y. So it was a very specific restriction that the x's had to be 2 or greater than, and the y's had to be 7 or greater than. And now we have graphed a ray. Now, we could easily graph, depending on what the equation was. It could be going up, it could be going down. That's still a function of this number right here, the slope. If it were negative, that would be going down. Okay, but we're going to be focusing on the x restriction. Okay, now I'm going to change one little tiny thing, and then I'm going to do one more example, and then we're going to be through this. Okay. The big change that I'm going to make is I'm going to take off this equal to. So now it just says, well, x is greater than 2. So now it says it can't be equal to. I'm not changing a single thing over here. I do exactly the same thing. I start at that number. Even though I'm not allowed to be equal to it, I still start there. Why do I start there? If you remember back to graphing on a number line, when you graphed an inequality, what did that change it to? That changed this dot to an open dot. That's it. That's what changed. So the inequality tells us what kind of array it is. That it's an array. As soon as we see an inequality, we know it's an array. I mean, it could be going up, it could be going down. It just tells us where we're going to start and that we're only going to go in one direction. We could go this way, this way, this way, this way. There's nothing saying it has to be one or the other, not at all. Okay? But if it's equal to, I'd shade that in. If it's not equal to, my starting point is an open dot. All the other dots are solid, but the starting dot is an open dot. Okay? So let's look at one more example. Let's make it all crazy. Let's go y equals negative 2x plus 3, and we're going to make our domain all the values less than negative 1. Whew. That's as involved as we can get, okay, because we're going to This is going to make the graph look different than what the last one did because it's a negative slope, so it's going to be going down as our eyes track from left to right. We saw that in the notes a few weeks ago. And this is going to really mess with us. So when we go to make our table, we have to choose -1, and then we have to pick values that are less than that. So let's go to -2 and -3. Be very careful. Remember, negative numbers, more negative is smaller, less than. Okay, don't pick 0. 0 is actually greater than -1. I'd rather have nothing than owe $1. And again, we still go through the exact same process. So y equals -2 times -1 plus 3. -2 times -1 is +2. 2 plus 3 is 5. Y equals -2 times 0. 2 times 0 is 0. 0 plus 3 is 3. And y equals -2. Oh, whoops. See, I did it again. I just did it. Because I'm so used to using 0 that I didn't even realize that what I just did isn't right. Because I didn't use 0. I used -2. -2 times -2 is +4. That makes a 7. And then -2 times -3, that's +6. 6 plus 3 is 9. So as this number is going down by 1, this one is actually going up by 2. That's what the -2 tells us. And you'll see it when we graph it. So again, here are my points: -1, 5, -2, 7, and -3, 9. My numbers are kind of big, so 1, 2, 3, 4, 6, 7, 8, 9. And I think I'll switch colors just for the negative sake. I'll pick red. I think red showed up really well last time. So -1, -5. Since that's my starting point and it's not equal, I'm going to be putting an open dot wherever that is. So -1, 5. 1, 2, 3, 4, 5. Because it is not equal to, so it is an open dot. And we go to the next one, -2, 7. So 5, 6, 7. And then -3, 9. So I go from my starting point, because this is how rays work. I go from my starting point towards the other dots. Boom, there's my ray. So my ray is actually going that way, okay? Because that's my restriction. My restriction is I can only choose numbers for x that are less than -1. That's this direction. So I'm not allowed to be over in that half of the graph even. Okay? That is how we graph a ray. So there's a restriction. Oh, and why don't we finish it up with what's my range? My range is it's going up. That means it's greater than. Well, we already knew it wasn't equal to. If this isn't equal to, this isn't equal to. If this is equal, this is equal. Those two things go together, okay? Because it's an open dot, so it's not equal to. Where did we start? We started at the number 5. So the range is y is greater than 5. The domain was x is less than or -1. That is graphing a ray. Okay, rays are very different. They're just an extension. We follow mostly the same procedure, except that this restriction, and this is the domain. Sometimes they'll even tell you domain. The domain tells us that we're going to have a ray, and therefore it also tells us that we're going to have a range that's not everything. Okay, so hopefully that helps, and I will see you in class or in office hours.